Welcome back to my channel. In this video, we will see the open loop configuration of an operational amplifier and the open loop transfer characteristics of ideal as well as practical operational amplifier. First, open loop. Open loop means there is no connection exists from output to input. There is no feedback. If there is no feedback, then that type of circuit is called open loop circuit. In op-amp, there is a three configuration in open loop. They are differential, inverting and non-inverting. Let us see one by one. First, differential mode. Here, the input is applied at both the terminals of the operational amplifier, that is inverting and non-inverting terminal. Here, Vs1 is applied to non-inverting terminal of the operational amplifier through this resistance R1, and Vs2 is applied to inverting terminal through the resistor R2. And we know that operational amplifier is basically a differential amplifier, so it amplifies the difference between these two signals. So here the potential is V1 and here the potential is V2, and this operational amplifier amplifies the difference between these two potential, that is Vd. So output is equal to AOL times Vd. This AOL is the open loop gain of the operational amplifier, and this Vd represents the difference between the two input signal V1 and V2. And here we are considering the ideal operational amplifier. We know that ideal operational amplifier draws no current. So here the input current is 0. So the potential drop across this resistor is 0. So this Vs1 is directly applied at this point V1. Similarly, the drop across this resistor R2 is 0 because there is no current, and this Vs2 is directly applied this point V2. So this equation can also be written as V0 is equal to AOL. Vd is V1 minus V2. Here V1 is Vs1 and V2 is Vs2. So this is the output equation of the differential mode operational amplifier. And if you are giving sine waveform and it amplifies the difference between the two input signal, and you get another sine waveform at the output. Next one is non-inverting mode. In non-inverting mode, the input signal is applied at the non-inverting terminal of the operational amplifier and the inverting terminal is grounded. Here Vs is the input signal which is applied to the non-inverting terminal of the operational amplifier through the resistor R1, and inverting terminal is grounded. Here this V1 is equal to Vs because here we are considering ideal operational amplifier. In ideal operational amplifier, input current is 0. So the potential drop across this resistor R1 is 0. So this voltage is directly applied at this point V1. So V1 is equal to Vs. V2 is directly connected to ground, so the potential is 0. Output equation V0 is equal to AOL times Vd. Vd is V1 minus V2. And here V1 is Vs and V2 is 0. So you get V0 is equal to AOL times Vs. Your input signal is amplified by a factor AOL. AOL is the open loop gain of the operational amplifier. So if you are giving sine waveform, then you get another sine waveform at the output without any phase change, and it gets amplified. Non-inverting mode, your output is in phase with the input. There is no phase difference between input and output. Next one is inverting mode. In inverting mode, the input signal is applied at the inverting terminal of the operational amplifier and the non-inverting terminal is grounded. Here the input Vs is applied to the inverting terminal through the resistor R1 and the non-inverting terminal is grounded. Here the output equation V0 is equal to AOL times Vd. Vd is V1 minus V2, and here V1 value is 0 because V1 is directly connected to ground. So the potential is 0, and V2 is equal to Vs because there is no drop across this resistor R1 since it is an ideal operational amplifier. So V2 is equal to Vs and V1 is equal to 0. Now we get V0 is equal to AOL 0 minus Vs. So V0 is equal to minus AOL Vs. This negative sign indicates there is 180-degree phase difference between input and output. Here also your input signal is amplified by a factor AOL. AOL is the open loop gain, and here there is a negative sign which indicates there is a 180-degree phase shift. So this is your input signal which gets amplified, but it is 180-degree out of phase with the input signal.